When document chunks are ingested into a vector database, we can attach metadata to them, which are key value attributes such as document name, page number, section, author, access level, etc. This metadata acts as descriptive context for each chunk, allowing the system to understand not just what the content says, but also where it comes from, who can access it, and how it should be prioritized. Metadata is not embedded with the chunk it is associated with, and hence, at the time of retrieval, users can apply filters on document attributes that are saved in metadata. One of the primary benefits of metadata tagging is query filtering. Instead of retrieving chunks purely based on semantic similarity, we can apply filters to narrow down the search space. For example, a user query can be constrained to only retrieve chunks from a particular time range or a defined department, such as payments. This has multiple benefits. It makes retrieval faster as we scope down the search to filtered chunks, and it also improves relevance as we filter out irrelevant or out of scope information, even if it is semantically similar to the query. Another use case for metadata is to provide citations and enable traceability. When a language model generates an answer, metadata allows the system to reference the exact source of information, including the document name, page number, and section. This enables responses to include citations such as source is Annual Report 2025, page 47. This not only improves transparency and users' trust, it is essential for auditing reliability of responses, especially in high stakes environments such as finance, healthcare, or legal domains. Metadata enables fine grained security by tagging each chunk with attributes such as user roles, departments, or sensitivity levels of the documents. During retrieval, the system enforces these constraints by filtering out any chunks the user is not authorized to access. This ensures that sensitive information, such as HR records or financial data, is never exposed to unauthorized users, even if it is semantically relevant to their query. Metadata acts as a critical layer for enforcing governance and compliance in AI systems. Another use of metadata is to provide data to the re ranking models for accurately reordering the vector search results. Many retrieval augmented generation systems use special re ranking models in production to reorder the vector search results and put the best ones on the top. This is done when vector semantic search returns relevant results but not necessarily in the right order. Reordering the results before they are sent to the downstream large language model can improve accuracy of response to the end user. Vector search results are typically re ranked based on their relevance with users' intent or their freshness based on the last update date or any other business criteria. Metadata can provide this data to the re ranking model. One popular use case is to create a contextual summary of the chunk during the pre processing stage and then save this summary in the metadata. This summary is then extracted along with the chunk and then passed to the re ranking model for re ranking based on relevance. In summary, metadata tagging elevates vector databases from simple similarity search engines into intelligent retrieval systems by enabling query filtering, access control, citation, re ranking, and also improving relevance of the returned results.